Picture this. You open your editor, fire up your favorite AI model, drop in a clever prompt, and in seconds it spits out hundreds of lines of shiny new code. For about 10 minutes, it feels like you just hired a genius senior engineer who works at light speed. Then the next 2 hours vanish into fixing weird edge cases, broken imports, and functions that almost match your real data model, but not quite. Here is the uncomfortable truth. The problem is not just the model. It is your entire AI coding workflow. Most people are stuck in what Ray Fernando calls the prompt and pray method. You type something smart, hit enter, and hope the model magically understands your whole project, your architecture, and every decision you made last month. It does not. By the third or fourth prompt, the model quietly forgets why you chose Postgres instead of Firebase, or why user roles live in a separate service. And here is the wild part. Top AI coders are not just writing better prompts. They are running a completely different system. The hidden enemy is something Ray calls context rot. Large models can juggle tens or even hundreds of thousands of tokens, but your real project blows through that with multiple files, API contracts, and half-remembered design docs. After a few back and forths, the model starts resurrecting old patterns you already refactored away, like bringing back a deprecated Stripe service when you clearly asked about the new billing client. In a minute, we will flip this on its head and turn context from a liability into your superpower. Context rot shows up in nasty, familiar ways. You see duplicate data transfer objects with slightly different shapes, naming conventions that drift for the same concept, and silent breaking changes to public interfaces. Instead of reviewing a tight, surgical diff, you get a messy grab bag of scattered helpers, duplicated logic, and inconsistent error handling. Each AI pass compounds the chaos, so debugging stops being about one bug and becomes reconciling three versions of the same feature. This is not just annoying, it changes who gets real work done and who drowns in cleanup. So Ray Fernando and Cole Medin push a different mindset entirely? Stop thinking of this as prompting a chatbot and start thinking like a context engineer. You are not just asking for code, you are shaping what the model knows, sees, and remembers about your project. Traditional prompt engineering optimizes a single message, but every message resets the model's real understanding. Context engineering designs the whole system around the model so it behaves like a senior dev, not a forgetful intern. Imagine two versions of your AI partner. In one world, it only sees the single file you pasted and has no idea why anything is structured the way it is. That is the intern. In the other world, it has a compact architecture overview, feature specs, data models, and dependency maps, all wired into every request. That is the senior engineer. Same model, radically different behavior. And in a moment, we will walk through the exact blueprint Ray uses before he even opens an AI chat. Ray's rule is brutal but effective: blueprint before build. He refuses to open Cursor or Claude until he has a written project doc that reads like a mini product spec, architecture sketch, and test plan in one. It starts with plain language feature requirements, real user stories, and explicit done criteria. He bakes in constraints like performance targets, latency budgets, and browser support, so the model cannot quietly optimize for the wrong goal. This alone kills a huge class of half-baked, almost right features. Then he maps the data flow before a single line of code exists. Entities, inputs, outputs, how data moves through requests, database schemas, caches, external AP is, and background jobs. If a feature touches authentication, billing, and notifications, each hop gets named and described up front. He also locks in the tech stack explicitly down to versions, so the model cannot randomly swap Postgres for Mongo or invent microservices when you wanted a monolith. The AI is allowed to be creative only inside the box you drew. That blueprint becomes the seed context for the entire AI session. Ray pastes it into a fresh chat and treats it like a contract. Every later prompt points back to sections of that plan instead of re-explaining the project from scratch. This blocks the model from inventing architecture and forces it to respect your decisions. No surprise auth system when you already use auth 0, no rogue queue when you picked a specific message broker. In a moment, we will zoom in on how he manages the model's memory like a scarce resource. Think of context like RAM for your AI pair programmer. It is fast, powerful, and absolutely finite. Modern models may handle from 8,000 to 200,000 tokens, but that window fills up shockingly fast with framework glue, third-party libraries, and your own half-documented services. Most developers burn this budget by pasting raw files until the model taps out, then wonder why it hallucinates interfaces or rewrites the wrong module. Ray flips this by treating context as a budget you invest, not a hole you dump text into. The power tool here is an automated project index. Instead of feeding 120 files, you generate a structured table of contents that is just a few percent of the repo size but encodes most of what the model needs. High-level architecture, key modules and responsibilities, data models and relationships, external AP is, and integration points. Tools like Cursor, Windsurf, or custom command line scripts keep that index fresh as the project evolves. You are giving the model a persistent design doc, not forcing it to bushwhack through node modules every time. On top of that index, Ray uses system prompts as a policy layer. In tools like Cursor, you can define standing rules such as never touch auth, prefer functional React components, or all new code must include tests. Those guardrails sit above any single message, so even when you are deep in a tiny diff, the model still respects your overall standards. High signal context plus clear policy beats raw volume every time. This is how you get consistent behavior instead of roulette with every new prompt. Now, here is a mistake almost everyone makes. They use their smartest model like a very fast typist. Workflow engineers like Ray and Cole treat it like a chief architect. You do not pay for Claude Opus or GPT-4 Turbo to grind out for loops. You pay them to decide what should exist in the first place. So they use top-tier models for high compression thinking, not raw code generation. The pattern looks like this. First, you ask the premium model to propose multiple architectures, compare them, and justify trade-offs around data models, API boundaries, and deployment. You have it write a clear technical spec with components, responsibilities, interfaces, and a stepwise implementation plan. Once you approve that spec, you freeze it as the single source of truth. Then you hand smaller chunks of that plan to cheaper, faster models to actually write the code in small, shippable diffs. This architect then execute workflow does two big things for you. It concentrates expensive reasoning into a few high-value passes, which controls cost. And it slashes variance because every change traces back to a vetted plan instead of whatever the model happened to remember that day. Over time, when requirements shift, you regenerate the spec, then rerun only the affected implementation steps. You stop chatting with a robot and start operating a build system for software ideas. Ray takes this even further with a divide and conquer approach using sub-agents. Instead of one chaotic mega chat, he spins up specialized threads. One for database schema and migrations, one for React UI, another for API contracts and integration wiring. Each chat has its own context, history, and constraints. The database thread never sees Tailwind classes. The UI thread never gets polluted with low-level Postgres tuning. You are mirroring how real teams split work, but with AI. This ruthless context separation fights a subtle killer, context pollution. When one overstuffed chat tries to remember every decision, it drifts into contradictions and half-remembered instructions. By isolating concerns, you keep each model instance mentally narrow and high signal, which cuts hallucinations and conflicting suggestions. Your main high-level conversation stays clean, focused on goals, constraints, and trade-offs. Sub-agents handle the how, but the primary thread guards the why. So what does all of this change for you, day to day? It means you stop treating AI like a magic vending machine and start running it like infrastructure. You design context, enforce policy, blueprint features, and orchestrate multiple agents. The payoff is real. Fewer mystery regressions, cleaner diffs, and a codebase that actually converges instead of drifting. And here is the deeper twist Ray points at. The end goal is to use AI to need AI less. By forcing yourself to write better specs, clearer architecture docs, and explicit constraints for the model, you are actually training your own engineering brain. Over time, you rely less on brute force prompting and more on solid design habits that would make any senior engineer proud. AI becomes a mirror that exposes fuzzy thinking and rewards clarity. The future Ray describes is not you as a prompt monkey. It is you as a conductor, orchestrating models, tools, and context into a reliable pipeline for shipping software. So here is your challenge. The next time you reach for an AI coding tool, do not start with a clever prompt. Start with a one-page blueprint, a lean project index, and a clear idea of which agent owns which slice of the work. Treat context like a budget, your best model like an architect, and your cheaper models like builders. If you want a deeper breakdown of Ray Fernando's live workflows or a follow-up on stack diffs and shipping discipline, tell me in the comments, hit subscribe, and stay tuned. Because the developers who learn to engineer context now are the ones who will own the future